welcome to my presentation. I'm really happy to give my presentation about my work to you. Today my topic is about development of 3D extension of GeoServer to handle the 3D spatial data. So first, I do like to introduce my team members. So we are from Busan National University in South Korea. Professor Ki-jun Lee is my advisor, and Dr. Jun-seok Kim gave a presentation to introduce the indoor spatial awareness server 2 years ago in First Project Korea. And this project is part of the ISO project that he initially designed. And I'd like to say and really thank you for Sujin Kim. She contributed a lot of things to this project. And I'm Hyung-gyu Ryu, today's presenter. Yeah. Hello. And 2 years ago, Dr. Jun-seok Kim proposed a project called ISA server at First Project Korea, which is systems for building and managing indoor spatial databases. And our goal was to develop indoor spatial data server as a open source. And in our solution, indoor spaces should be treated as a three-dimensional geometry. Each room or corridor in the indoor spaces is represented as a cell space with solid geometry. And many queries for indoor spaces are performed for 3D geometries. So, for example, some queries between people's trajectory and room or corridor, we need 3D geometries as well. So due to the advantage of open source project like maintenance and modularity and scalability, and we wanted to develop such a spatial server for indoor spaces as a open source. So, but you may be disappointed if you come only seeing at the title. I cannot say this project is super perfect and all functionalities for 3D are provided and performed very well. And because we are very small laboratory in the university, so the main developers of this project is just 2 people. Yeah. I believe that if I share my problem and experience with you on this project, I think it is worth it. And because I think it is a really new challenge that nobody tried before. And anyway, I'm here to meet new volunteers who has a lot of time. And because my only one colleague of this project will graduate this year, and I'm really hurried now. So I want to say first, why do we need GeoServer really? And then I will talk about our system, and I will show you some simple demonstration, and we'll talk about next steps and summary. So I'm going to start from motivation, and this is common open source architecture or software stack for 2-dimensional GIS. And left side of this is data source layers, and the right side is application layer. And between them, there is a geospatial server. We have a lot of projects that we can use in this stack. And for example, PostGIS or S3 save files are for data layer, and one is on the database management system, and one is file. And QGIS is for desktop client, and Open Layers is for some web client. And why we need a geospatial server between this data store layer and application layer like GeoServer? Just to service geospatial data to user for just simple things, actually we do not need general geospatial server. And you can develop your super server to connect PostGIS with JDBC and some other GIS files by parsing them and share your data to clients by kind of RESTful API, which is defined by you. And also, other super developers can make their own servers for their purpose. And also, in this architecture, a client need to implement a lot of code to consume your maps or data or service. And this is what a mess. We cannot repeat the same things like connecting DB or service to clients, such like that. Our life is really short. Yeah. So in this architecture, also, users may need to overlay and manipulate multiple layers from various data sources like PostGIS or S3 or other types without concerning about different implementation on each data store. And also users may want to query some spatial operations using standard protocol from their client application without knowing SQL. Yeah. So we have spatial data server or library for general purpose like GeoServer. So now we have several open source software tools dealing with 3D spatial data such as CGM.js, iTown, and NASA World Wind. And these tools that have been actively developed now are mainly focused on the visualizing 3D data in a client environment. And also there are several database management systems that can store 3D spatial data and perform 3D query processing. And one of the representative commercial database, the Oracle Spatial, support 3D spatial data types, including solid geometry, and also support the 3D spatial operations. And about our friend PostGIS, one of the popular open source spatial database, several 3D operations and 3D polyhedral surface like that are supported by SFCGA extension from 2013. So, what about 3D GIS comparing with 2D GIS architecture? So, is there a server that supports connection to various data source for 3D data source and can be shared as a standard web service? I believe that the architecture for 3D will not be different compared to two-dimensional, but now it is nothing. So you can say that we have 3D CDDB. Yes, they did a lot of works, and they support data structures with 3D geometries inside. And web feature service also supported for sharing data, and web service client such like that. Yeah, they developed 3D full GIS stack, but this project is for storing and managing virtual 3D CD model. So they only focus on the CDGML format established by Ojushi. So can we add the new data stores like PostGIS or related other data formats for dealing 3D spatial data? Yeah, we can now. So it is not just general purpose server for 3D. So to create a 3-dimensional spatial data server from this motivation, we can set these 4 requirements. And first, 3D spatial server should support data structures to store a feature with 3D geometries, including solid geometries. And second, also it should support functions to process queries on 3D object, like a 3D intersect or 3D more distance like that. And third, it should provide a connection to data stores to store like 3D spatial information to some other data DBMS system or files like that. And fourth, we need standard web service for sharing our three-dimensional features with three-dimensional geometries. Yeah, I think GeoServer meet this requirement perfectly in two-dimensional. I expect that GeoServer will be able to be distro in also 3D like that. So I want to just briefly talk about the GeoServer. And yeah, GeoServer is a representative open source spatial data server in open source field. And it is implemented based on GeoTools, and it provides a variety of spatial data sources. We can just implement and like plug in, and we can add a lot of data sources. And GeoServer also supports geospatial web services like web map service, web feature service, and web processing service like that. And GeoServer has that's why they support a variety of spatial data source, and they support web service like that. They support excellent abstractions in their kind of data structure inside. So GeoServer express all kind of spatial information as a feature. In the right side, data is feature, and they define the type of like shape of feature as a feature type. So for curing a filter, the information present in the like where clause, they define a filter or expression like that. And by these interfaces, GeoServer can support a variety of spatial data sources from data store. So data store is a kind of abstraction, and from the a lot of format of the spatial data, they just focus on how to transform from a lot of data format to feature. And also the upper side of feature source, the feature source is kind of high-level API for operation on feature data. So user can access geospatial information as just feature. So and so user don't have to think about the details of data store or data formats. This all geospatial information is just feature. Yeah. So now GeoServer has limitations in handling 3D. We cannot deal with 3D data with G coordinate. So, but we just can store 3D points and curves and surfaces. Yeah, but it is impossible to store spatial information like solids. And spatial query processing is performed without G coordinates. And why? JTS is really good library, and JTS gives a lot of stable geometry operations and fast. Yes, JTS geometry can carry a G coordinate to their geometries. But what about solid geometries? And what about 3D spatial operations? And JTS is just based on the OGC simple feature access, so they don't have to have solid geometry class, something like that. And now in their spatial operations, even geometries has g coordinates. They ignore g coordinate when they perform the operations. And furthermore, in terms of extensibility, JTS is implemented as class-based. So even if fancy geometry libraries that has superpower of functions are newly developed, it is hard to replace them. So it is necessary to replace JTS for GeoServer to provide fully functional features in 3D. So we have, yeah, fortunately in GeoServer, actually GeoTools has interfaces of ISO 1907 spatial schema in OpenGIS module. So yes, so yeah, it has solid geometries and it can support 3D operations as an interface level. But in GeoServer they have ISO 19107 implementation, but it is also just support two-dimensional operations. So to support three-dimensional operations, we have two options. The first one is we can develop all of things to support 3D operations. And second, we can reuse or utilize existing open source libraries. And although the first option could be optimized for GeoServer, but we need a lot of effort to make all of things. So we chose second one, but something wrong. Yeah, but and we had two options to choose some libraries, and we don't have time. And anyway, we choose simple feature CGAR because CGAR is different from those in GIS domain, so we were hard to connect between GeoServer and CW Plus libraries. Anyway, so as I said before, SFCGAR is a library written in CW Plus, and to invoke functions in SFCGAR, we need a bridge between native CW Plus and Java. So we use Java CPP. Java CPP can generate wrapper classes corresponding to SFCGAR, and from this wrapper class, we can invoke functions in the SFCGAR. So yeah, so we connect the SFCGAR functions by this architecture. And this is example of the performing the 3D operations. So we have ISO 19107 geometries, and by some converting between ISO 19107 and SFCGAR, we convert to their data structure, and we perform the 3D operations, and we can get results from Java CPP library. And yes, we make a new ISO 19107 geometry module, and we support easy installation and we support 3D operations, and we can use it at least. But now it's not done, absolutely not. It is a long way to go. So next, we examine the GeoTools and GeoServer from bottom to top, and we found that codes are coupled with JTS from the ordered modules because it supports excellent abstraction, but all codes are assumed JTS. Geometry is just JTS. So we take a simple strategy. First, we use well-defined interfaces in GeoServer GeoTools, and we copy and rewrite classes to support ISO 19107 geometries if the class is coupled with the JTS geometries. and we just leave code that not coupled with JTS as much as possible. And first, for copied code, perform unit test. Yeah, it is really simple strategy. Yeah, Control C, Control V, and rewrite. So from this strategy, we support 3 data store and 2 data management system (DBMS). So yeah, you can use it. Yeah. I will skip this. This is a really detailed one. And also, to share our spatial data, we extended the web feature service for 1.1 version. So 1.1 version of the web feature service supports GML 3.1.1, and 3.1.1 supports solid geometries. Yeah. So we developed the encoding and decoding method between GML and ISO 1907. And this is the flow of our the process. So yeah, you can see this. Yeah. So this is our result. This is result of our project now. So we extended many modules to support 3D geometries. Yeah. I wanted to show you some demonstration, but I think I have no time here. So if you want to see the demonstration, come to me and I will show you. Yeah. So next step we have it is done. Yeah. 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 We need documentation, and we need administration GUI for 3D. And for some user want to use JTS library for 2D, or for some user want to use 3D geometries by using the ISO geometry. So we need some kind of switch between JTS and ISO geometry. Yeah. And we will support web features of 2.1 later. Yeah, and we will test and improve again. And this is about, we have a pure web feature service, so next time we can support tiling like that. Yeah, this is summary. Yeah. Thank you for attention.
Time for one question. We'll break for lunch. Anything additional you'd like to say? Yes.
One quick question. So what is your timeline? Like, I suppose you have a desire to bring back some of these changes to the GeoTools and GeoServer official repositories. So what is your timeline to get to these changes back in, like, not depending on the JTS directly and so on?
To get in the official GeoServer. Yeah, yeah, I will. I can say to more mailing list like that, but in GeoServer there are many issues now. So after talking with committers, I can set some timelines for them.
So we can take additional